Okay, instead of using a dozen, which is 12, chemists use something called the mole, which is abbreviated MOL, and it is equal to 6.022 times 10 to the 23rd things. Okay, so the mole came from the concept that in 12 grams of the carbon isotope, carbon-12, Avogadro found there to be 6.022 times 10 to the 23rd atoms. So this is, by definition, the mole. Avogadro's number is 6.022 times 10 to the 23rd. And if you look at the periodic table at carbon, carbon has a number underneath it of 12.0107. Since this number lies so close to 12 grams, which is where we experimentally determined the mole from, then that means that this is called the molar mass of carbon. So 1 mole of carbon is equal to 12.0107 grams. And in my class, we take the molar masses 2 places past the decimal and you round it if necessary. So if I relate all of the other elements in the periodic table to this carbon concept being the mole, or 1 mole of carbon is 12.01 grams, then that means that all of these fractional numbers underneath the elements in the periodic table are the quantity in grams in a mole of that element. So the molar mass for fluorine would be 19.00 grams per mole. Oxygen would be 16.00. Hydrogen would be 1.01, and so on. Okay? So if I'm looking at student exercise number 1 and I'm looking at copper first, okay, what I want to do is get the molar mass for copper. So in 1 mole of copper, you will see on the periodic table it has a number of 63.546. So that's going to become 63.55. So 63.55 grams per mole is the molar mass for copper. Okay? If I want the molar mass for mercury, I would look at the periodic table, and here it is 200.59. So make sure you include your unit of grams per mole. Okay? Now, this is for pure elements. If we want to do something like a compound, then we're going to take a look at student exercise number 2. So for student exercise number 2, I gave you 2 different compounds. The first compound is potassium sulfate, which is K2SO4. If I look at potassium on the periodic table, potassium has a mass of 39.10 if I round it 2 places past the decimal. So we've got 2 potassiums in this chemical formula, so it's going to be 2 times 39.10 for my potassium. And then what I'm going to do is I'm going to add that to the mass of 1 sulfur. So sulfur is 32.065. That means you need to round it to 32.07. So we're going to add 1 32.07 for my sulfur. Then I'm going to add 4 oxygen. So oxygen is 15.9994. I need to round that to 16.00. So it's plus 4 times 16.00 for oxygen. Okay? And when you add all these together, you're going to end up with 174.27 grams per mole. Now, in my class, we are using this periodic table for all of the calculations involving molar masses. You may not use any other periodic table. This is the periodic table I will give you on exams. And the reason why I don't want you using any other periodic table is it's going to throw your answers off by, I don't know, maybe a 10th or 100th of a place. So you don't want to do that. Okay, so just use this one, make a note. You always have to use this periodic table for the math this semester. Okay, now, if we're looking at a different kind of compound, one that is known as a hydrate, which you don't see very much of in an introductory chem class, but I still have to teach it to you. It looks something like this. It has a little multiplication symbol between the chemical formula and waters. What that means is water is attached. Okay? You're not going to be multiplying the mass of NiCl by the mass of 6 waters. You're really going to add the mass of 6 water to NiCl. So what we're going to do here is take 1 nickel, which is 58.69, plus 1 chlorine, which is 35.45, plus you have an option here. Either add the mass of 6 waters or 12 hydrogen and 6 oxygen. The choice is yours. You'll get the same answer in the end. So I'm going to go ahead and add 12 hydrogen and 6 oxygen, like this. Okay? So here, I'm going to end up with 202.26 grams per mole for the molar mass. Okay? And now you're ready to do the worksheet on molar mass, which looks like this. Okay? And you've got 5 problems. It's worth 10 points. It's a point for the right molar mass. It is a point for the right unit. Your molar mass has to be identical to the one that I calculate using this periodic table, which you have a copy of, which is also posted on Canvas. Okay? Now, in order to keep you thinking about nomenclature, in number 2 and number 3, I didn't give you the chemical formulas for aluminum hydroxide and ammonium phosphate, which means you have to write them. That means you're crossing charges. That means you have to have your old periodic table with all the nomenclature tricks on it. Okay? If you don't have that because you turned it in with your binder, then you can print it out from Canvas, or you can get it out of your old binder, but you have to leave the old binder in my classroom. Okay? All right, so you're going to do the molar mass worksheet, and then that's it.